All right, we've got paper 1, question 8, which reads, what is not a statement of one of Newton's laws of motion? Choice A, let's consider each one. If body X exerts a force on body Y exerts an equal and opposite force on body X. I really like the way that's worded because it reminds us that we always need two objects to interact, and that's really as a statement of Newton's third law, right? Equal and opposite forces between two objects. The other thing to be mindful of with Newton's third law is that those forces must be of the same type. So if it's a gravitational force, a non-contact force, there's another gravitational non-contact force that corresponds. If it's a contact force, like the normal force, then there's a equal and opposite normal force, contact force. Just because forces are equal and opposite doesn't automatically mean they're a Newton's third law force pair. For example, an object that sits on a table has its weight acting downwards and has the normal force acting upwards. And indeed, those are equal and opposite. So a book that sits on a table doesn't accelerate, which means the weight acting down is equal to the normal force acting up. Those forces are indeed equal and opposite. They are not a Newton's third law force pair because they're acting on the same object. So this reminds us body X, body Y. We'd be saying, well, what are the other objects then? There's an earth down here that the book is pulling up on with equal sort of force, weight. But because the earth is so much more massive than the book, if we were to remove the table, the book would seem to accelerate towards the earth and not the earth accelerating up towards the book. But indeed, the physics is they both accelerate towards each other in proportion sort of to how much inertia they have. So the earth is so much more inert, it hardly moves at all. The normal force is interacting with the table. So the table, if the table is pushing up, then the book is pushing down on the table with an equal and opposite normal force. And we usually use prime, so like the normal force prime for that. And we usually don't care about those Newton's third law forces because if we're studying the book, we only really care about the forces acting on it. So don't confuse the fact that just because forces are equal and opposite, they're automatically a Newton's third law force pair, right? You have to sort of know it a little bit more carefully than that. The second one says, if no resultant force acts on a body, it has constant velocity. That sounds like, Newton's first law a little bit. So let's keep on reading through. The rate of change of momentum of a body is proportional to the resultant force acting on it and takes place in the direction of the force. That sounds pretty good. And then D says the total momentum of a system of interacting bodies is constant if there is no external force. And so I think all of those are true statements. B is really talking about inertia, like an important constant velocity is 0, so rest. So if something's at rest, it remains at rest. If something has some other constant velocity, some non-zero constant velocity, it's going to stay that way unless some resultant force acts on it. That means if it changes its direction, forces are required to do that, right? Because velocity is a vector. So it can have the same speed, but accelerate by changing its direction. That would require a force to do that. So I always like to think about the first law as things don't accelerate on their own, right? Resultant forces are required to cause that. So that's the first law. C is the second law, right? That says force is the rate of change of momentum. And D is just a statement of the law of conservation of momentum, which I think it falls out sort of as a consequence of this, or maybe that was used to derive one of the other ones. Read Newton's Principia and make it more clear to yourself. But choice D is the correct answer to this question. It's not one of Newton's laws of motion.